So good morning from my side. Everybody wake up. And so thanks, Ilan, for introducing the cluster for Linux. Yeah, it's our, let's say, peer solution. The mainframe cluster is there for many years, and we have many successful customers and new ones coming in. Yeah, we just recently closed a nice design and architecture deal for a major bank. So mainframes are still investing a lot to make their infrastructures also very secure. So that's important. And bringing this to the Linux side prepares us on the infrastructure side to make Linux comparable to a mainframe. Obviously, different infrastructures, but we need to make the functionality available also on Linux, and that's what we did with the Adabas cluster that for Linux that Ilan just introduced. And previously, Ellie also talked about high availability. So that is building a very resilient architecture on Linux. That's the demand from the market. Maybe some of you started here many years ago where the only thing that we needed to take care of was making the application available. Then the response time was the challenge, make it very low all the time, so availability and response time. And now high availability is coming more and more. So that's becoming a kind of standard everywhere because of the criticality of the applications, right? So my name is Luciano Pimenta. I work as a senior principal architect on the Adabas Natural business unit. And today, on top of what my colleague said, we're preparing the resiliency of the infrastructure, but now we need to also take care of a very important aspect, which is security on Adabas for Linux. And that's what I'm going to cover today, okay? And I would like to start mentioning some of the aspects around security, right? So we have, if you put a hats on from a DBA or a security manager taking care of Adabas on Linux, what aspects should we take care of? So there are many different ones. We maybe should cover some of them here as an introduction. For example, we need to make sure we need to secure the configuration of our databases. We put the database up, we set the configuration, and we need to make sure that that configuration is stable and kept always in a controlled way. And typically we suggest to avoid, for example, playing with the configuration parameters because this can be critical for the life of the database. And also shutting down things that you don't need. And I give you an example. So we are talking about security, and we have a TCP/S port, which is a secure port of the communication with the database, but we could also have a non-TCP port. So that could be a flaw. So let's set the non-secure port and disable it because we don't want nobody using that port. So that's a kind of example on how to secure the configuration of the database. Some others don't think about patch management. So patch management is also very relevant. We need to be always patching our system with the latest fixes available because that brings the highest level of fixes for the functionality of the database itself, but also on security aspects that you might encounter. So that's a recommendation. And possibly up to the latest versions. That's also important because then you have the latest functionality in the database. So that's a relevant aspect. Backup and recovery. So all of us as DBAs, we have a plan on how we should take care of backup and recovery. But most important is we should play with the recovery part. Because we don't expect having to recover it. That's the reality. But we need to play with, and we see customers having a mandate by compliance to have a recovery of the system each and every 6 months, just to prove that it can be done in the the need of that a crisis is happening or emergency is happening that they need to recover. So that's a very important part of the plan to secure the environment, okay? We have other aspects, and I will cover them, like authentication, authorization, auditing and logging, and encryption. But we will see this along the road today. And if we map then this, let's say, security aspects that I just mentioned into our great Adabas on Linux, we can map this into solutions and capabilities, right? And we'll see this today. So, for example, the encryption part that we'll cover, the RBAC, the role-based access control, that maybe some of you know about it, maybe it's something new, we will also see about this. And also the SSL trusted relationship to Natural, or in other words, Natural to Adabas trust. That's something more recent we did, and I would like to introduce this also to you today, okay? But since we are talking about security on Adabas Linux, I must mention, and because this is there in a kind of legacy mode, but it's there, we still support, which is the, let's say, the traditional ciphering capability that we have. We also have this on mainframe. It's a ciphering by value. It's there in the software, could be potentially used, but obviously we are in favor of recommending the Adabas encryption for Linux on this area. And also the Adabas security. Maybe you heard about it. We also have this on mainframe, Adabas security capability, which is a feature of the Adabas mainframe, but also a feature on Adabas Linux and could be used. But these kind of solutions are there. We are not backing this off the Adabas code base, but typically more modern solutions can be adopted in replacement for this type of solutions, if you eventually use them. So, let's start talking about encryption then. So, as you know, Adabas is a mission-critical database, and typically our customers are storing very sensitive data in Adabas. So you can imagine what types of applications you as a customer you are processing, but basically financial data, credit card transactions, or health information, and passport data. So in all these sensitive areas, we have customers playing with Adabas. And this is obviously more and more considered what we call sensitive data, or personal identifiable information, right, PII. And therefore, we need to take care of security, doing security of this data, protecting them, because that's the critical part, data protection. And this is done sometimes by pressure from business, but also from compliance reasons, as we will see. So that's what we did when we decided to create Adabas encryption for Linux. So that was a demand, strong demand from the market, from our customers, and Adabas encryption is done and it's ready to be used, and that's our solution. And what aspects can we consider when protecting data, sensitive data with Adabas encryption for Linux? So you can look at different ways on this, but basically making sure the confidentiality of the data is kept, okay? If data is eventually stolen, if someone can get into your system and eventually pick the data files of Adabas, they would not get access to the real data, because the data is encrypted. They will need a decryption key to be able to decrypt the data. So you are protecting your business data. That's what it's all about. So we are preventing the famous insider threats, as Bob mentioned yesterday. So this is part of the zero trust approach. So insider threats are very high, as Bob pointed out yesterday. So this also needs to be taken into consideration when planning and deploying Adabas encryption. And in the secure data sharing, so whatever the data, if the data is encrypted in your database, but also being encrypted while the data is shared among clients or among applications which are requiring the data. So protecting the data end-to-end by encrypting all paths of the communication. So that's very important, okay? And as I mentioned, compliance. So I would say that's the most relevant aspect that we see from our customers, and I will mention in a moment one of the success cases that we already have with Adabas encryption, but it's all about compliance. So every industry has its own standards in terms of security and compliance, and customers dealing with Adabas and storing data from those industries are required to be in alignment with those mandates in compliance. So all in all, if you think that everything is fine, everything is protected, everything is secure, but needs to be also taken into consideration the, let's say, the regulations and compliance aspects. So that's a very interesting part of it. So let's look on how it works. So we're talking about encryption, and here we have our Adabas, and we have two major use cases for encryption. So we are talking about the secure data in flight, which means exactly the communication path between a client application, for example, Natural in this case, accessing Adabas data. So this communication should be encrypted, especially when talking about distributed architectures, where potentially we have client application running in remote nodes against a local Adabas sitting in a different node, and the communication and the data is actually flowing between the two nodes. And if you don't secure that and you don't encrypt that, this is done kind of in plain text. So someone could sniffer the information in the network, for example. So it's a very important aspect of the protection of the confidentiality of the data flowing from this application. And that's one of the use cases. So Adabas is able to provide us a secure port for communication, for remote communication. So that's one aspect of it. And the other aspect is data at rest. So that's the data sitting on the Adabas containers. And Adabas container is always mixing up with the container terminology that we have from the cloud. But here I just want to make sure that we are talking about containers. And for us on Adabas Linux side, we're talking about associator, data storage, work part of the database. So those are the containers, okay? So just to differentiate the terminology here. So data at rest means then these containers from Adabas will always be encrypted at rest while they are written, they are stored on the file system where those containers are sitting. This is obviously activated by a product code, Adabas encryption for Linux. AEL is our traditional three-letter product code that we have for this, and it's then enabling this. The remote communication also requires an entire network license key. That's to enable the ADA TCP ports, okay? What else? So we've been evolving this solution recently, since we released it first version. So now, as you see here, we can also encrypt additional elements that, in my view, are also part of the database. I consider them part of the database, of course. If you take a backup, for example, it's not the primary database, but contains the, let's say, a snapshot of your data. Therefore, it's part of the database, can be considered that way. We can then also encrypt the backup outputs of the ADA save utility on Linux, okay? And also the plogs. Plogs, as we know, the protection log stores the transactions, update transactions that happens in the database. Therefore, it contains business data inside. Therefore, it's also very relevant that the solution can encrypt the plogs. And that's what we are doing now. Important, we are also expanding the key store capabilities. So you can imagine we are securing and encrypting data in the database. We need encryption keys for this, right? And we need to store the encryption keys somewhere. And now we are expanding the support for the Microsoft Azure key management systems. We previously also supported Adabas encryption keys on AWS, key encryption mechanism, but also on file system. If you are not in the cloud, you can just store it on a dedicated place in the file system on-prem. That's not a problem, okay? So both use cases provided by Adabas encryption for Linux, data in flight, data at rest. Important to mention, no changes to the applications. So this is fully transparent from the application point of view. That's very relevant. I'll explain you why. When we are approached by a customer and they say, we want to protect the data, what can we do? First question that comes, what should we do on our application side of the house to allow us to work with encryption? And that's a good question, and the answer is very simple. Nothing. Nothing needs to be changed from the application. Fully transparent. Just like it is, by the way, as Ilan pointed out, for the cluster also, okay? Nothing needs to be taken into consideration. Also from natural high availability point of view, application is totally non-touched. You don't need to change anything. That's very important because facilitates the deployment of such measurements in terms of security and distribution of the architecture and increasing the high availability of the solution. So it's an off-the-shelf. By the way, we built the encryption capabilities inside the Adabas code base. Therefore, you don't need to install a new software piece or software component from us to enable encryption. The code base is there, it's just triggered on and off by the license key of Adabas encryption for Linux, okay? Moving on then, what should we do to encrypt the database or to encrypt, let's say, the communication? So for the data in flight, which is the first use case, obviously we need keys. So we need to provide the keys, we need to configure the Adabas nucleus with the proper parameters to have enabled, for example, the SSL port number. We need to define the secure port number for communication, and we need to provide the CA file, the certificate, and the key file. So this is something that obviously your security guys will create for you, specific for database usage, and then you just need to store this and point this into the configuration of Adabas, okay? And from the client application point of view, Ilan also pointed that out, that we have the DB mapping, and he did even make a quiz about where it's sitting, and obviously now in the last version of Natural, you can also possibly use NatParm for this. We have a RDBMS parameter area in NatParm of Natural. You can also put these parameters there, but basically you are pointing to a logical database, and you are defining the protocol as secure, as you can see, maybe on the back not, but there is an S here after ADA TCP, and we point the IP address or server name and so on, and all the certificate that you want to use for the client application, okay? And for the data at rest, so what we need to do? We need to encrypt the database. We have a non-encrypted database now, and what we need to do? We need to encrypt it, we need to put the parameters, and then the process of encryption is done at a restoration of a backup. So we have a database which is not encrypted, we want to encrypt it, we just back it up, and then restore with the encrypting parameters. In this example here, we are putting the 256-bit XTS mode. We support 128 or 256. I'm selecting the most secure way with 256. And while the data is being written back to the database, it's been automatically encrypted from that point on. And when restoration is finished, you just start up the database, you see this database is now encrypted, and then you are safe to go, okay? And automatically a key store is then, an entry to the key store is then created for the database that you have been just encrypting by the restoration process, okay? So that's all about encryption, and it's very good to see customers adopting it, but most important, customers solving problems with the solution. So this particular customer is an insurance company in Puerto Rico, in the Caribbean, and one of the most important entities in this industry in the country. And what was the problem? They deal with private data, personal identifiable information. They play with health records. So it's demand. And again, on the technical side, everything was good. We are protected. We have our capabilities. We have this and that. We have all the pieces, bits and pieces, as you like to say always. But that's not compliant. I'm sorry. Unfortunately, compliant mandates are pushing, and in this case, they were under pressure. And this PCI DSS, for example, that's one of the things that they need to comply with, because they process credit card information and store this data in Adabas. They are under pressure to say they're audited every 6 months by PCI DSS, and if they don't comply, eventually they have to pay penalty. Penalty means business money that needs to go just because the compliance was not fulfilled. So that's not good. And so immediately we say we can encrypt the data, but there was a challenge. They were not running the latest version. So that's the secure part I mentioned in the first slide. It's always good to be on the latest versions because of all the security aspects that we can imagine, but also on functionality side. And in this case they were not prepared because they were on a back level version of Adabas. So we need to upgrade them to the latest version and then be able to encrypt the database. But that was done in a short period of time, and they were able to encrypt the database, and now they are ready and are safe, and they can rest without problems with the auditing, okay? And it's hard to the IT guys to tell to the upper management, which sometimes is not really knowing down to the bits on how this is done, but the guys up there were just saying, it's not encrypted? Why are we being audited? So can we encrypt the data? Oh, yes, we can, and that's what they did, but, they had to do this in a process. But now they are safe. That was good. That was about encryption. And now let's move on, and let me introduce you to the role-based access control, or in short, RBAC. Easier to say, RBAC. And RBAC is a methodology. It's a functionality, by the way, in Adabas. It's not a product from the Adabas family. It's a feature. It's a function that is there, sitting in Adabas, and any customer can explore to enhance the security capabilities of Adabas. And it's typically explained if you look this from a triplet: authentication, authorization, and auditing. So that's what we can get out of RBAC. And basically, authentication means we can validate the credentials from a user wanting to read data or access data in Adabas in an authority. We will see which authorities can be used. So this means we are identifying who is accessing the data. And why? Because if not, without RBAC, Adabas access can be done by any request. So no authorization is required. It's open, anyone can access. Okay, so RBAC is very interesting because it forces you to authenticate a user into the database. That's very important. We can also do authorization, which means we can assign permissions to which data in Adabas a given user who has authenticated before can access. So we are really defining on a more fine-grained way who can access what in the database, right? And this is done by assigning roles to users, and we will see this in a moment, which then represents the selective privileges that this role and this user can have in the data, in the database. And to mention here, since we have a mixed audience, so the mainframe guys can recall that on the mainframe side, our customers can have the ability to exploit the Adabas soft security, which means, for example, RACF or top secret, let's say, rules can be applied or to authorize users against accessing Adabas. I need to authenticate and authorize this in a SAF server. So this is similar solution from the mainframe, but now on Linux can be done with the RBAC. That's the similar solution here. Or we could say that on open systems, typically the customers are doing this on the application side. For example, in Natural, eventually Natural Security, you might say, yeah, I authenticate a user in Natural Security, but actually that's not happening in Adabas. SQL Gateway, Adabas SQL Gateway from Connex. This can also be done like that with a user authentication, or even in Java applications. But this is on the, let's say, on the client side, not on the database side of the house, okay? And last but not least, auditing. So if you have implemented RBAC, we can also have auditing capabilities in terms of writing out a log, for example, for security violations or attempts. Actually, we can track everything, but recommendation would be to track only the violations, not the successful ones, okay? Let's see a little bit in more detail how it works. Let me start with the security model. So RBAC works with this security model. We have users, we have roles, right? And we have, let's say, a combination of objects and operations, which means an operation can be applied to an object and then assign it to a role, which is then assigned to a user. Looks complex, but it's not. Actually, just basically groups. I have a group of users, I can have a group of roles, and etc. So I can have some granularity level here to say who can do what on a role level on the objects that I have, which are database files, and also the Adabas utilities that can be also controlled by RBAC. And the operations are the basic ones we expect. Execute, for utilities especially, I want to execute or not a utility, I have authorization to do that or not. Or I can read, insert, update, delete, obviously in this case file against object files, okay? And then I associate this with roles and users. Let's see how to set it up. So authentication can be enabled, and we use AdaDBM for those on Linux. In this case here, they know AdaDBM, the utility we have. Database maintenance utility. In this example, maybe you can see, database 20, security can be set to warn or to active. So I recommend, strongly recommend, someone going into RBAC, play with warn mode, which means what? Means that we are kind of active but not effective. So we are writing audit trails, we are checking the stuff, but we are not enforcing. But this is good for preparation mode, where while you are setting up your roles and your permissions, you play with warn mode so that you can be safe, okay? And why you can be safe? Because once role-based security feature has been enabled, it cannot be disabled. Obviously, it would be a security flaw if you could just disable security for now because I want to do something special and then I return security. So that's not security, right? So that's not possible. So once you put in active mode, then it's done. Security is in place, everything needs to be managed through RBAC, authorizations, users, roles, and etc. This is then enforced. Then this was authentication. We have also authorization, and then here we have a kind of, it's not new, it's there for some time, but maybe not so known utility, which is other RBA, and I can then initialize the RBAC file. Okay, so we have an RBAC file. Interesting, because then we have a new file. It's a system file controlled by Adabas, of course, but we need to create this, and this is created by this utility here that you see. You can just give your number, preferred number, and it will be created and managed fully by the Adabas nucleus. Don't need to take care about this. And in the last version of Adabas, we enhanced this setup, and now this file can be created in any block size that you might have. Customers having different block sizes on Linux for the data storage and for the associator. So now this is supported in any block size that you might have. It was not like that before. And the audit trail, as we said, we can have auditing, and you can see here, we can turn auditing on and off, and you can filter to have written out all the records, successful and violations, or only rejected, meaning only the violations, which I recommend because then that's what we're really interested in, and it's then less effort for the database point of view, okay? And from the authentication authority point of view, we have different ones here. The operating system, locally, we can have a text repository, which is the example I basically use it here. I can create my users in this internal repository, which is local. And we can also have LDAP, very famous LDAP, and also Active Directory. We can play with different authorities and check the authentication against those, okay? Briefly give you 2 examples of how to protect things here using RBA. So that's the administration part. And the RBA utility can create, drop, grant, revoke, and list the permissions you have. So let's assume 2 examples. And starting with one example to say, let's secure the access to the employee file. And by the way, it's file number 11. So what I'm doing here, I'm running other RBA, DBID20. I'm creating a role, and I'm calling it HR Dept, HR department. And then I'm granting an operation, any operation, into object 11, which is the employee file, to role HR department. Basically, I created the role, and I granted an operation for that role, okay? Then I create an HR user and grant the role HR Dept to the user HR user. I basically associated that new user into that role that I just created before. And then I grant the operation read to object 11 to role public, okay? So I think that's a mistake here. That's the old version. So I grant role to the HR Dept, in fact, okay? So I'm just saying only the HR role can read data. And then I can deny the read access for that object for all the other public users. So everybody outside of HR would not have access anymore, okay? That's how RBAC works. And if you look, for example, in a Adabas DBM utility, if I want to, let's say, protect it, I can create a role database administrator, for example, and then I can grant this utility for this role, and I create a user DBI user, and then associate that user to that role and revoke the public for all the other users I revoked or blocked user of this other DBM utility. So I give permission for a group of people and revoke from the others. So that's what RBAC can do for us, okay? On a more granular level. Good, but then we protect Adabas, so Adabas is protected. Everybody to get access into Adabas requires authentication. So we can say, now we have a problem. How can we do this from Natural? And that's why we created recently the Adabas Natural Trust, which is something very nice in my point of view, because otherwise, in an RBAC-protected Adabas nucleus, you would need to provide user and password using an user exit 21 in Adabas, so that Adabas would allow you to get into. That's not very flexible, and user exit to do this kind of thing. So basically, that's a very nice solution. And let me tell you how it works briefly. So basically what happens here is, if Natural client is presenting a valid certificate, which can be authenticated by Adabas nucleus, then Adabas will trust this user, this client user, and will not require user and password anymore, because it's trusting that this guy is a known guy and an authorized guy to get access to Adabas. And that's done, basically, obviously, we need ADA TCP communication. Even locally, by chance, I must say that, if you are monolithic still, application Adabas running together, they can use ADA TCP, okay? It's not only when you are remote. You can use it even in a single node architecture. So that can be done also locally. And the SSL trust is a new parameter that you can have in the Adabas nucleus in the DB configuration file, SSL trust equals natural. This will enable a trusted client providing a user ID using the certificate. And in this case, Adabas will skip the authentication and you just apply the RBAC rules for that user. That's it. And if a user is not presenting a client certificate, okay, Adabas will just authenticate the credentials of that guy using the extension security system that we have, for example, LDAP or Active Directory, the ones that I mentioned in this slide before. So if a valid certificate is presented, that's fine. That's coming natural from natural client. Adabas will accept it and just apply the rules and let it go. Otherwise, you could just authenticate outside using the standard supported authentication authorities that we provide. Okay? Coming to close to the end, I always like this pyramid for Adabas on Linux and cloud because it shows us, let's say, the different levels of encryption or the security levels that we have, which starts with encryption of sometimes given by the operating system or by the infrastructure provider to say that the disk is already encrypted or eventually taped. But this is an area where we don't play as software AG. We don't play here in this area, but some providers potentially do it. Then we have on the file and data set encryption side, we have Adabas encryption playing the job here. So the more we grow, we have the solutions that addresses the security aspects of those, and here is Adabas encryption. So we are doing this at container level, as I explained before, for the data at rest. So that's the Adabas encryption for file and data set encryption. If you go up a little bit, and we see here access control and database encryption as well. Again, ciphering can still be used, not recommended anymore, as I mentioned, but we maintain this for compatibility reasons in the Adabas source code and the code base. But here we prefer and recommend Adabas encryption also for Linux, and this is covering the data in-flight use case, okay? And for the access control, which is data in use case, let's put it that way. Data in use means, yeah, who is accessing the data, authentication, etc. So that's RBAC. And you have it as a functionality in Adabas. And obviously, last but not least, application encryption. Someone could say, I can encrypt my data in my application, which is something very hard and complex to do, and we would never recommend that. But that's part of the, let's say, concept of how to protect data anyway. And just to close the session today, then my typical 3 key takeaways. Evaluate and access your security environment for Adabas. Have a look at it, all the aspects that we mentioned here, maybe some more. Please have a look, all the strategies that you have, all the demands that you have. And if you have compliance reasons to think of Adabas encryption to protect your sensitive data, let's talk about it because it's there. It's easy to implement, and it's a quick win for you, let's put it that way. And the protection is done with no application changes. Again, it's non-invasive, so it's easy on this aspect. No changes to the application is required, and then you can be fully aligned with the compliance without having to demand your development teams to implement something. It's there on the infrastructure of Adabas, and we can just plug and use it, okay? So that was it from my side for the secure Adabas on Linux, and thank you very much.
Do we have any questions? Yes, we do have questions. Great. Test.
Thank you. Is security by value included in RBAC? For instance, a role may access the salary of an employee only if it's less than $100,000, for instance.
No, that's not covered in RBAC currently.
But it would make sense, of course.
Makes sense, secured by value, maybe on the scope of the pyramid, maybe it's a valid use case, I would say.
Thank you.
Just a question regarding maybe some compliancy as SOX for American companies. And we didn't talk about CM or this kind of tools that, because SOCs involve for us to store overlogging regarding the access to the database and these kind of things. Is there any new connectivity to these kind of tools as Splunk or Elastic-CM or these kind of tools?
Well, we can provide auditing records, as we explained it. You can also have C-log records being printed out for any access in the database. And once it's stored in the file system, you can just pick it up and store it anywhere else. So we don't see a problem in that. So you can have the last mile of this important shipped to anywhere you want, basically. Flat files. You can export, for example, C-log records, process them with the other CLP utility, print them out as standard text records, and ship it anywhere you want. That's what I see customers doing.
Regarding security, identity management, you were talking about Active Directory and so on. I suppose, are you implementing standard protocols as OpenID or SAML or this kind of things to normalize the authentication as well as the authorization, as you described?
Yeah. So what we are working on is it's a more comprehensive approach for security based on tokens, which will then maybe solve this challenge. So a token will be created, and wherever the user is going, flowing from a natural application into Adabas or eventually into an RPC server, a token will be created at the beginning of the session, and then the token will flow with the user wherever it goes. So that's the concept that we are designing in the PM teams, in Adabas Natural PM teams currently.
So just a word on that. So currently it's on progress, the development of token-based solution. And we also expect that RBAC will inherit that in the token-based solution also for the authentication. So it will be based on OpenID Connect in order to enable authentication on the Linux environment. The next stage will be also for the for the Windows.
Do you have a question, Chris? I see your hand up.
On the encryption side, how KMS or key aware are your Adabas utilities? So, for example, we use plogs and we use AdaPLP for post-processing. How aware of those are they of encryption?
Yeah, if the plogs are encrypted, the AdaPLP, for example, which is the plog management utility, if the plogs are encrypted, the keys will have to be accessed.
So AdaPLP can encrypt the data
yes.
to process it?
Yes.
Good.
Any other questions? Thank you very much, Luciano. We're going to take a break.